So on Tuesday of last week, you know, when the weather turned, okay, and you guys were actually still here, we went over acceleration. All right, so I'm just going to quickly review what acceleration is. Then we're going to walk through 4 examples of acceleration, which is actually what we did on Thursday. For those of you that were here, okay. For those of you that weren't here, I recorded it and posted it, but I made 4 more new questions that we'll go over today. Okay. So things we need to remember. Okay. Acceleration is any change in velocity over time. That could be speeding up or slowing down, changing directions or whatever. Okay. Any change in velocity is an acceleration. Okay. An acceleration, because it's the change in velocity over time, can be calculated by taking, oddly enough, not VF minus VF, the change in velocity divided by time. Right? And when we do that, what units do we get? Meters per second squared, which is another way of saying meters per second, which shows us the rate at which our velocity is changing. This many meters per second every second. Right? So there's obviously some manipulations of that formula that you will need to do. Okay. Obviously, you cannot use a triangle anymore. If you've been depending on that and hiding it from me, too bad. You can't anymore. Okay. It just won't work. Okay. Now you have to actually do algebra. Follow the rules of algebra. Reminder: the rules of algebra are: if I want to move something, I do the opposite. What I do to one side. And I always move what's not attached to what I'm looking for first. Okay, that's important in this formula. Okay, all right. I would like you guys to try question number 1 about a plane landing on a runway at a velocity of 200 meters per second. Over a 15-second interval, it slows at 6.5 meters per second squared. What is the final velocity of the plane? Okay, this question is designed to help you become aware that context in a question is important. Okay, so as with any problem-solving type of question, especially in basically any question in physics, okay, the first thing I want to do is write down my givens. Right, so my givens in this question are that I have an initial velocity of 200 meters per second. Okay, and I have a time of 15 seconds, and it slows at 6.5 meters per second squared. Here's where context is important. That's negative 6.5. Okay, so guys, I hear a bunch of out there. Okay, so when you did this question, and you didn't make 6.5 negative, you got that the plane was going faster after it landed. Agreed? That's where context is important. The question specifically says that the plane slows down. So if you get an answer that's bigger, then you know you did something wrong. And you probably all recognize that. Okay? But now you recognize what you did wrong. And it's important that you can do that in a question, especially on an exam, because that's going to happen sometimes. You're going to forget some small trivial detail, like putting a negative sign on something, and you'll get an answer that doesn't make sense within the context of the question. If it doesn't make sense, then definitely check over what you did. Read it again and see if there's something you missed. Okay? I will never have a question on a test whose answer doesn't make sense in the context of the question. Right? Okay, so acceleration needs to be negative, and we are looking for VF. So you would get a mark for your givens, and you would get a mark for choosing the correct formula. I know right now we're only doing acceleration at the beginning, but by the end of the unit, when we've got a whole bunch of other formulas, you get a mark for picking the correct formula. Okay, I need to solve for VF. I need to move t first because it's not attached to VF. So I'm going to multiply both sides by t. So I'm going to have a times t equals VF minus VI. I want to solve for VF. What do I do with VI? Add it to the other side. So I'm going to have a times t plus VI equals VF. All right. So you would get a mark for your manipulation, and then a mark for plugging in our numbers correctly. Negative 6.5 times 15 seconds plus 200 Okay. All right, so we're looking at 102.5, except I have how many significant figures here? I always go with the least number of significant figures. Okay, the smallest number is 2. Right? So I have to actually put this number into what? Into scientific notation. All right, so that means that my decimal needs to move to this point right here. So that's going to be 1, 2 spots. So this is going to be 1.0. Like so. Okay. Questions on that one? All right. Try this one. It's one of those questions that doesn't seem like it gives you very much information, but it actually does, especially if you have your formula sheet out, because there's some stuff on there that might be useful. Okay, so this question seems like it doesn't give us very much information. If something falls off of a cliff or is dropped, what's its initial velocity? 0. Okay, so that's one of the things it gives us without outright giving us a number. Okay, now, good question just came up here. How many significant digits does 0 have? The answer is as many as you want. You can't measure nothing to any certainty, so you are absolutely certain you have nothing. Okay, so there's no significant digits on 0. It does not affect your significant digits for your answer because you can't measure nothing. Okay? All right. The other thing it gives us is VF, 42 meters per second. And since we can assume this rock is falling on Earth, what's the acceleration? 9.81. Okay, we're looking for T. So A equals VF minus VI over T. In order to solve for T, I have to take it from the bottom and move it over to the other side so that it's on the top. So basically, I'm just going to switch A and T here, and I'll have VF minus VI over A. When I plug in my numbers, that's going to be 42 minus 0, okay, divided by 9.81. Right? Now, technically, 42 and 9.81 are in the same direction, and it's both down. Do I need to make that negative? No. As long as I know it's down and there's no change in direction, I'm okay. The only time I have to make 9.81 negative is if I throw something up in the air. Okay? Then I've got an upward movement and a downward movement. I have to reflect their opposite. Okay, so when I do this here, okay, I will get my time. So 42 divided by 9.81. That gives me 4.28, but I only have 2 significant figures, so that's going to be 4.3 seconds. Okay, everybody all right with that one? Yeah, good. Okay, try this one. You have a race car that reaches a velocity of 80 meters per second after accelerating at 4.5 meters per second squared for 12 seconds. Okay, what is its initial velocity? Give me a couple minutes on that one. All right, so for question number 3 here, we have a final velocity of 80 meters per second. We have an acceleration of 4.5 meters per second squared, and they basically infer that that's in the same direction as the 80. They don't really outright say it, but we have to infer that. Okay, for 12.0 seconds. Okay, we're looking for the initial velocity. So A equals VF minus VI over T. This is the trickiest manipulation of this formula. Okay, I don't like to end up solving for a negative number, and that's what you can end up with when you do this. All right, so I manipulate it a little bit differently, because if I solve for a negative, I always forget it's negative, then I get the wrong sign on my answer and I get it wrong. Okay, so I never solve for something as a negative. All right, I'm going to multiply both sides by t first. So t comes over here. Okay? Now, at this point, I could just subtract VF over to that side. But when I do that, VI stays over there, and it stays negative. Right? So what I do is I actually add VI over to here. Now VI is positive. Right? But obviously I'm not solving for it yet. I'm supposed to be isolating VI. Well, what can I do with t times a now? I can just move them back over there by subtracting them, okay? Because you have to think order of operations. I would multiply these two numbers together before I add it to VI, right? So it's really just one number, and I can subtract it over here. Right? So now I'm solving for VI, and I'm solving for it as a positive. The other way you can look at it is this way, okay? T times A gives you the change in velocity. So if I want to find the initial velocity, I would take the final and subtract how much I changed the velocity by. That would give me what I started with, okay? And vice versa. I take VI and I add the change, that will give me VF. Okay, so there's two ways to kind of look at that. All right, so we're going to have here VI equals VF minus T times A. All right, so we plug in our numbers here, and we'll have 80 minus 4.5 times 12. Okay, so we're getting an initial velocity of 26 meters per second, and I only have two significant figures, so I can leave it like that. Everybody all right with that one?
Did you put like a positive on it because it's...
Well, no, actually I don't. I should, because it says velocity, but they never put a direction on theirs in the question either. Okay, so in a case like this, I'm really not solving for velocity. I'm actually solving for speed. Okay, obviously I would do a better job. So I would put positives or north or up or something. Okay, last one. And this one you're solving for acceleration. Probably the easiest one because there's no manipulation, but this is probably the toughest contextual question that I made. All right, so on this one, context is important. The car is initially moving up the hill, but at the end it's moving, which means it's accelerating backwards or downhill, right? So I have to put some positives and some negatives in here when I'm doing my math. All right, so runs out of gas while moving up the hill. So VI is going to be 6.5 meters per second uphill, okay, which I'll make positive. Okay, and then VF is what is 3.78 meters per second downhill, which will be negative. Okay, my acceleration is what I'm looking for, and the time is 8.52 seconds. All right, so acceleration is VF minus VI over t. So like we said, we don't have to manipulate this, but we do have to make sure we get the signs right when we plug everything in. So VF is negative 3.78 meters per second minus 6.5, which was positive or up the hill, divided by time, which is always positive, 8.52. Okay, so we have negative 3.78 minus 6.5 divided by 8.52. Right, so I get negative 1.2 meters per second squared, which I will actually not write as negative. I'm going to write 1.2 meters per second squared downhill. Okay, my vector needs to match what I was given in the question. Even though I end up having to convert everything mathematically to positive and negative, I need to go back at the end and reflect. My answer needs to reflect what I had to start with. All right? Everybody okay? I mean, some people are lost. Okay. So, what I want you guys working on now are the questions from the workbook. I know you didn't get to those with the sub there on Tuesday, okay? And obviously we didn't have class again really after that. So, I I'm going to put the questions from the workbook up here, and I want you working on those, okay? And then tomorrow, we'll be starting work energy theorem, which is probably the biggest thing in this unit. Work energy theorem is where you get the energy from to cause things to happen. I want you guys to start out with question number 2 here. Don't worry about question number 1. Start on question number 2. I'll make those a little bit bigger, okay, in case you're not looking at them on your phone. All right. So you can start out with question number 2. Okay, there's a few, where it'll ask you to calculate time, and then there's a few in a row where it'll ask you to calculate VI, a few in a row where it's VF. Okay, kind of just pick a few here and there. All right, so you get a chance to kind of try them all. Okay. Okay, so the trick to number 4 is not like algebra or anything like that. The trick is that you have a number given to you in scientific notation. All right, you have to make sure you enter it into your calculator in scientific notation, just like you would, Avogadro's number from Unit 1. So what we have here are that the acceleration is 800 meters per second squared. Okay, we're looking for how long it takes it to get from rest. From rest means that it started not moving. Okay, to a final velocity of 2.5 times 10 to the 8 meters per second. All right, 800 has how many significant figures? 3. How many does 0 have? All of them, right. And how many does VF have? 2. All right. So A equals VF minus VI over T, and we're looking for T, so that'll be VF minus VI over A. So we'll have 2.5 times 10 to the 8 minus 0, okay, divided by 800. All right, so when we do that in our calculator, okay, it's going to look like this. So we're going to bracket 2.5 E8. Okay, and since we don't have a VI, it's 0. We don't have to do anything else for that. Just divide that by 800. Right? So we have 300. Well, that answer should actually be to 2 significant figures. It should look like this. It should look like this. 3.1 times 10 to the 5 seconds, which is what it looks like on your sheet. Okay? Questions on that one? Once in a while, you're going to get a question where you are given a number in scientific notation. Just keep it in scientific notation.